We have been working a lot during the 4 years of this project, but today I prepared the work that we did in EPFL in the year 2012, which is the most recent work we did so far. So first I would like to explain about the importance of emotion visualization. There are lots of different types of communication in 3D cyber worlds, such as a virtual agent, like assistant who answer to the question automatically in 3D. And there is also MMORPG games like World of Warcraft and multi-user virtual world like Second Life. And also in the research side, there is a lot of different type of VR application with 3D graphics. And most of them are using online with the communication, especially on text-based form, textual form. But here, for the communication, the emotion is always important because in the text, emotion is always transferred or transmitted between people. So the important issue and our goal is to achieve real-time 3D visualization of the emotion. To do this, since our layer is output layer, we had a lot of help from other cyber emotion partners, such as modeling emotional model from psychological point of view, for example, or how to convert the textual input to the emotion. And also how to simulate the emotion in a time domain with emotional dynamics, and also a virtual agent. So there is mainly two parts on this presentation. First, for visualizing emotion, we mainly focus on the facial expression of a virtual human. So there are different type of different way to simulate emotion in computer graphics. There is a facial expression or body movement or something like that. But we focus on the facial expression because during the communication, mostly people are watching the face of the human. So basically, in this presentation, more than 80%, I will spend more than 80% on this asymmetric facial expression. And second, we developed a pilot software that allows the user to do effective communication in online virtual world. So I will show a demonstration at the end about this software. So why facial asymmetry? I prepared some kind of quiz. There is a text on top of this slide. A photographer named Howard Schatz asked to an actor to give a static posture of emotional face to an actor. So this photographer showed this text to the actor, and the actor actually performed the emotional expression about this situation. So the situation is you are politically ambitious prosecutor trying a sensational murder case, and you've just realized that the defense's key witness has given you a huge opening to prove that he's lying. This is the situation. And actually, so you can imagine how it will be. And the actor actually chose this kind of expression for this situation. So if we take a look on this facial expression, we divide the left side and right side of the face to see how it looks like if we duplicate. So this facial expression is a face. We duplicate the left side of face to symmetrically, and this expression gives more like a bored or so it expresses some different emotional feeling. And if we make a symmetric face from the right side of the face, from the actor's point of view, the expression looks more like a relaxed, so it shows a completely different emotional feeling. So that's why, especially in graphics, computer graphics field, this asymmetric facial expression was not really researched on the computer graphics domain. So since it's a very challenging problem, we wanted to focus on these issues first. And then since we are working on the real time, we try to find a fast and intuitive way to control this facial expression. To do this, we discussed and we did some literature survey on psychology, because we are not psychologists, and there was some interesting findings about the facial asymmetry from the psychologists. First is when a human expresses an emotion, the left side of face is known to be more intense in the expression. But of course, there was a debate later, so it's not settled in this way. And due to the social convention, also people try to hide their emotion, and sometimes the left side and right side of the face looks differently. So we would like to, so as I explained, we did a lot of literature survey on psychology. So before we go through the framework, how to make the asymmetrical facial expression, we would like to show you the basic terms of what we needed for constructing our framework. So the first is a very famous emotional model. I think all of you know already what it is. It's a valence, arousal, and dominance 3D model of emotion, and also known as PAD model. So we use, basically we use this VAD coordinate for expressing the emotion, for the input of the emotion. And for the emotional model, we use the affective norm for English words, because we just consider the communication as an English language. So in this affective norm of English word, we have 1,040-something number of English words, and each English word. So the author of this research has asked to the experimental subject to find out the valence and arousal and dominance coordinate of each different emotional words. So, for example, for happiness emotional word, the average result was 0.8 for valence, 0.4 for arousal, and 0.4 for the dominance. Here, the range of this valence, arousal, and dominance is from -1 to 1. Actually, during the experiment, the range was from 1 to 9, but I normalized this value in order to use in our system. And another example, there is anxious. Anxious valence is more or less neutral for valence, and the arousal is quite high, 0.5, and the dominance is a little bit higher. And for example, for the relaxed emotion, as you know, the arousal is very low. It was -0.7. So with this emotional word and VAD model, we also use a famous facial action coding system, because we had to animate each facial part of the virtual characters. We defined 12 basic units of facial movement, like eyebrow movement, or eyelid movement, or mouth opening, head orientation, or stuff like that. So by combining all this notion, we finally was able to simulate 3D facial expression from VAD coordinate. So this is one part of the framework. And the other part, with this VAD to face coordinate, we also combine the asymmetric research on asymmetry in psychology. So this image shows, it's a paper published in 1978, I think, from Sakai. It's written here. And this was, I think, the first paper that was published about the fact that the left side of face gives more intense feeling of emotion than the right side. But later, I think Ekman was published another paper to say that it's not true and blah, blah. So let me first, with the VAD to facial expression, I would like to show you how we generate a facial expression from the VAD coordinate. So first, we take 18 emotional samples from NU table. And then we defined, from facial action coding system, we defined 12 facial part basic units and try to find the relationship between the sample and each face part. So in order to explain the face part, I have prepared a simple demo to show what is this facial part. So, for example, there is a movement of the eyebrow, or the movement of eyelid, bigger, smaller, or mouth opening, or head orientation. So in total, we have 12 different basic units to animate the facial expression. And then at the end, we try to find the dependency between each face part to the VAD coordinate with our method, which I will explain more in detail later. And this was all the pre-processing stage. So before using this to 3D World, we just do some kind of pre-processing to calculate everything before we use it. And at runtime, we give any kind of any type of VAD value, and finally we can have immediately a facial expression from the VAD input. So here is a more detailed explanation about this observed intensity and defined dependencies. So we basically fill the table, as you can see here. On the left, you have, as I mentioned, 18 emotional sample in VAD, where we find from NU table. And then on the column, we have each 12 facial parts, eyebrow movement, eye movement, and nose movement. And we fill the intensity value. Here, the intensity value is, as I show you, the FPA movement. If it is -1, is so from -1 to 1, it changed the movement of a basic part of the face. So the first 6 row of emotion, the emotional word is the 6 basic emotions, as you know. And there are lots of research from Ekman about this facial expression on the basic emotion. So we use this literature to fill the intensity value. And we had an internal observation about the other emotion to fill all the table. After filling all the intensity of this table, at the end, we have 3 coefficients, each coefficient for each emotional axis. And with this coefficient, we were finally able to simulate the facial expression. There is some linear regression method, but since it's boring, I will pass very quickly. And finally, what we get from this, so we have an interface where we can give a valence. So this axis is valence axis. This axis is arousal axis. So we can give any VA value plus the dominance of the face. So for example, if we give low arousal and high valence, we have this type of face. if we reduce the dominance, it suddenly change, and we can increase the dominance or valence. So we can change. We can give any type of kind of VAD value to generate the emotional facial expression. And since we have NU table, we can choose any type of word in NU table to have immediately the feeling. For example, anxious or relaxed, for example. Relaxed. So we can give an emotional face directly from a word. And with this VAD to facial expression framework, we can create different type of asymmetric facial expression. And the asymmetric facial expression is created with a very simple method. So we choose two different emotional words for left side of face and right side of face, like happy and afraid. And there is some manual editing process to refine the both side of facial expression. And then finally, we apply those two values for the left and right side of the face. And finally, we have a more complex expression with two different emotions in one face. So the face edit parameter is quite simple. As I show you the slider, after choosing an emotional word, we can modify the VAD or the weighting of VAD or the distance between two different emotions. So we can control these values to refine the facial expression. So here is two examples of how we made the asymmetric face. So first I will show you how we make a smirk expression. We combined a neutral face for the left side of the face and a happy emotion for the right side of the face. And we bias a little bit more to the left side to show more happier on one side. And finally, we get an expression like the lip corner is slightly up, goes up for the right side of the face, which gives a smirking expression. There's another example, pretend to be cool or okay. We combined an anxious emotion for left side of face, because someone is actually anxious, but the person tried not to show that she is anxious. So another face we combined with the relaxed emotion. And we modify the valence. We put the higher valence to the anxious emotion to hide this anxious feeling. And also we increase more the relaxed expression to really hide this anxious situation. So finally, we have this kind of expression. We have a video about how we make this pretend to be cool. So first, we choose the anxious emotion for the left side of the face. And for the right, we choose a relaxed emotion. And then we control the edit value to refine the facial expression. So in this way, we create the pretend to be cool emotion. But as you know, emotion is somehow very subjective, so we need some kind of validation process, evaluation and validation process to know if it works well or not. As I mentioned at the beginning, the real-time, our framework is supposed to use in real-time framework. So we have tested in a very crowded 3D scene. So we populated 200 virtual humans in a bar scene, and we randomly generated a symmetric facial expression for 200 characters. So this video was taken in real time, and it was simulated in more than 60 frames per second for 200 characters, which was the maximum in this case. And so we have 5 minutes. So we had another evaluation in a crowd scene. This experiment was to find out how the emotional facial expression influence to the virtual human. But since we are running out of time, I will just show you the crowd scene with emotional facial expression was more realistic than the crowd scene without the facial expression. So if you are interested, I can tell you later more detail. And then as I said at the beginning, we developed a software for affective communication. Of course, the facial asymmetry was included in this software as a main module. And we used the Unity game engine platform to consider the commercialization and the stability of the software. So this software can be run in multi-environment, like a VR system in immersive cave, as you see in the image. Or it can also run, this application can also run in a desktop or laptop, or even in a mobile phone. But we never tested, actually, but we have a compiling option. And also, it runs in cross-platform. It can be run in Windows, Mac OS, Android, or even Unix, Linux system. And since it's online, for the networking module, we use RACnet, which is software made by Jenkins Software. We use this for the communication between softwares. I forgot to mention that with the asymmetric facial expression, we also embedded the sentence strengths. Professor Michael Thelwall presented yesterday is included here. And also emotional dynamics from ETH Zurich, the presentation this morning, the first one. I think it was the first one. Was also, by collaboration, we included also this module in this software. So here is the demo. When you connect to, so first you can choose different type of avatar. Let me try with this one example. And you can choose the number of people, maximum number of people in the room. So you can even go to 1,000, but we never tested actually. So let's start simply with 2 persons. So the scene was created like this, and I made another avatar will join this server, and you will see the room here. Let's say we select this character. So the window is very small, so we cannot see clearly. So here is one avatar, and here is the other avatar. So in this window, the avatar is her, and in this window, the avatar is this guy. So the woman can type, for example, I am happy, for example. And you will see her emotion. As I said, the emotional dynamics is included here. So you will see the VAD value evolving over time. And if you give another input, you have, I think, more happier face. And sometimes it's linked with body emotions. Meanwhile, I can also type a different type of feeling. As you see, the red cross moves because the sadness emotion is more negative, and you will see the face. And also, because of this emotional dynamics, the listener also affect the avatar's emotion. So there are lots of different type of. So you can also give a manual input instead of text. And on your right, you have this many dynamics parameter made by ETH direct team. So you can control to actually change the personality of people according to these parameters. So, okay. So the conclusion, there is still limitation about this work. First of all, as you see already, the asymmetric face is not fully automatic, so we have to find a way to make it fully automatic for simulation. And also, if there is a lot of avatar in one scene, it's difficult to define the 3D, the camera view of the people, because a lot of people talk at the same time and we don't know really what's going on. So it's really important to exploit this 3D viewing in a scene. So now we are working on the evaluation of asymmetric face. So we already had around 60 subjects to find out if our asymmetric framework is okay. And in the future, we hope we can find a fully automatic way to simulate asymmetric face, or also conduct some experiment to find out some new phenomenon in 3D virtual world about this affective communication. Thank you very much.
Just a few minutes for questions. Have you got any other plans for future work with facial expressions?
Yes, as I said, there is a lot of different ways to improve this method. First will be the fully automatic simulation, because now there is a manual editing process. So if from the evaluation, if we can find some good way how to express the asymmetry, I think we can be able to simulate in real time. And also it's possible to, because now the emotional dynamics we are using from ETH is just for one symmetric face. We have one VAD value. So if it is possible to simulate two different VAD tracks, like for emotion and the other one for social convention, we can also use this kind of dynamics to simulate asymmetric face. But yeah, it's not an easy work to do. Okay, thank you.
Does it take a lot of computing power to add the emotion layer to the simulation?
Actually, it's just we give an input VAD, and we actually just simulate the VAD, change each part. It's just a simple matrix computation, and nowadays in a GPU, a matrix calculation is very fast, so we don't need any special computing power for this.
Any other questions? Okay, well, thanks so much, AJ.
Thank you very much.